Hello friends, this video on probability part 5 is brought to you by examfear.com. No more fear from exam. 50 seeds were selected at random from each of the 5 bags. So there are 5 bags and each of these bags has 50 seeds. And 50 seeds from these bags, each of these bags were selected, or assume they had 50 seeds. And they were kept under standardized condition favorable for germination. After 20 days, the number of seeds germinated in each of these bags were counted. And the bag 1, so 40 seeds, bag 2, 48, 42, 39, and 40. Right? So 40 seeds from bag 1, 48 from bag 2, 43, 42 from bag 3, 39 from bag 4, and 41 from bag 5 actually germinated. So we have to find the probability of more than 40 seeds germination in a bag. Please know it is more than 40. So more than 40, how many? 1, 2, 3. So probability of 40 plus is what? More than 3? More than 40? 3 cases by total number of cases 5. Correct? That means 33 bags, from 3 bags, more than 40 seeds were germinated and total number of bags were 5. So it is 3 by 5. Please note it is not 4 by 5. This 40 is not included because it is more than 40. It is not 40 or more than 40. Right? So it is 0.6. Similarly, the second question. Probability of 49 seeds in a bag. There is no one. There is no one. There is no bag from which 49 seeds were germinated. So it is 0 by 5. That is 35, more than 35 seeds in the bag. So more than 35, if you see, we'll count 1, this is more than 35, this is more than 35, all are more than 35. So more than 35, we calculate, this is nothing but total number of events which has more than 35 by total number of events, that is 5. So that is 5 by 5, that is 1. Right? So for the probability of more than 40 seeds in a bag getting germinated is 0.6. The probability of 49 seeds from a bag is getting germinated is 0. The probability of more than 35 seeds from a bag getting germinated after 20 days is 1. Correct? Why this is 5? Because all these events satisfy this. Why 0? None of the events satisfy 49. Why 3? Because 3 of these events here, 48, 42 and 41 satisfy the condition of more than 40. In a cricket match, a batsman hits a boundary 6 times out of 30 balls he plays. Find the probability that he did not hit the boundary. So out of 30, 6 is boundary. Then how many not boundary? Obviously 30 minus 6, that is 24, is not boundary. So probability of not boundary is what? Total number of events when we had no boundary, that is 24, by total number of events, that is 30, and that is nothing but 0.8. Similarly, if you want to find probability of boundary, that is not asked, nothing but events when we got boundary, that is 6 by total number of events, that is 30, that is 0.2. And if you add these 0.8 and 0.2, you get 1. Because we are covering all the scenario. We are covering not boundary and we are covering boundary. Because when you hit, either you get boundary or you don't get boundary. Correct? Even if you are out, that is not a boundary. So it covers all the scenarios. 1500 families with 2 children were selected and the following data was recorded. So number of families with 2 girl child 475, number of family with 1 girl child 814, and the number of family with 0 girl child 211. We have to find the probability of having 2 girl child. So probability of having 2 girl child is how much? Total number of cases when we have 2 girl child by total number of families, that is 1500. This is the value. Similarly, probability of having 1 girl child is scenarios when we have 1 girl child by total number of families. Probability of 0 girl child is what? Families where we have 0 girl child by total number of families, that is 1500. Correct? Also check if the sum of these probability is 1. Yes, if you add this actually you get 1 as the answer. Why? Because we are covering all the scenarios. We are covering scenarios of 0 girl child, 1 girl child, 2 girl child, and there is no overlap. You can try this. You can just add these values. You get 1 as the answer. 3 coins were tossed. Please note, 3 coins are tossed simultaneously, 200 times. So if you throw 3 coins, you either get 0 head, you get 1 head, you get 2 head, you get 3 head. If you are considering that as a sample space. So your sample space will have 0 head, 1 head, 2 head or 3 head. Correct? And the frequency of the different outcomes, if you see 0 head, 1 head, 2 head and 3 head is noted. And they have done this 200 times. Add this 200 times. So we have to find the probability of getting 2 heads. Okay, so now we have to find the probability of 2 heads coming up. So probability of 2 heads is what? Number of times 2 head. Number of times you get 2 head by total experiment count. So number of times 2 head is what? 72. Total number of experiment count is 200. And that is 0.36. That is the probability of getting 2 head. Similarly, probability of getting 1 head will be 77 by 200. Probability of getting 3 head will be 23 by 200. Probability of getting 0 head will be 28 by 200. An organization selected 2400 families at random and surveyed them to determine the relationship between the income level and the number of vehicles they have. And the following data is obtained. Right? We have to find the probability when a family is chosen and it has this is the earning and this is the vehicle. So if you see, the 2400 families are distributed across this table. So you pick one family and what is the probability that the family will be in this category of even. Even is nothing but earning of 10,000 to 30,000, that is this range, and exactly having 2 vehicles, this. This is my even. Correct? So probability of even is what? The sample space where even occurred is 29 by total number of families, that is 2200. Right? So probability of E is nothing but number of family satisfying E by total number of family. And total number of family in this question will be 2200 always. So number of families satisfying this condition even is 39. So we got this as the answer. Let's mark this as E2. So we'll find E2. So probability of E2, what is E2? 1600 or more per month. That is this range. And exactly 1 vehicle. That is this one. This is E2. So probability of E2 will be 579 by 24. Similarly, let's find E3. This is E3. Earning less than 7,000 per month and does not have any vehicle. So less than 7,000 is this range and 0 vehicle is this range. This is E3. So probability of E3 will be what? Number of families satisfying this E3 condition, that is 10 by 24. Let's find E4. E4 is what? Family is having income of 1300 to 1600, that is this much, and having more than 2 vehicles. More than 2 vehicles, please note, is families having 3, 4 vehicle, not right. Family having 2 vehicle will not be there, calculated, right? Because it's more than 2 vehicles. So more than 2 vehicle, if you see, is the only option in this one. This E, right? So family having income of 13 to 16k per month, having more than 2 vehicle is 25. 25 by total number of family, that is 2400. So that is the answer. Let's take E5 condition. E5 is earning 30 into 1600. This is E5. Owning not more than one vehicle. That is owning 0 to 1 vehicle, and the salary is not even considered. So this range is my E5. Correct? These families own 0 or 1 vehicle and the salary is not even considered. So probability of E5 will be what? All these scenarios just add 10 plus 160 plus 0 plus 305 plus 1 plus 555 plus 2 plus 469 plus 1 plus 579. You add all these things and you divide by total number of families, that is 2200, right? And if you solve this, you get 2062 by 24. These are the families which has 0 or 1 vehicles. Not more than 1 vehicle means 0 or 1 vehicle. Okay. Let's take a few more examples. We have to find the probability that a student obtained less than 20% in the math test. So less than 20% in the math test, this is the sample space. So probability of 0 to 20% is what? Number of students who got this marks, that is 7. By total number of students who got this mark, who in the sample space, that is 90. And that is 7. Students who got 60 or above marks, that is these two cases, 60 to 70 or 70 and above, both this will satisfy. So student who got 60 plus marks, nothing but 15 plus 8. And if you want to find the probability, divide by total number of students, that is 90. So you get 15 plus 8, that is 13 by 23 by 90. That is the answer. Probability of 0 to 20 is 7 by 90. Probability of 60 and above is 23 by 90. To know the opinion of students about statistics, survey was conducted among 200 students and the data is recorded. We have to find the probability that students like statistics and they don't like statistics. Example, this boy loves statistics, this lady hates statistics. So probability of like statistics is what? Students liking statistics by total student count. Total student count. In this case, liking statistics is 135 by total students count is 2. Similarly, student dislike statistics. Number of students who dislike statistics is 65 by total student count is 200. This is the probability of students liking statistics. This is the probability of student disliking statistics. And if you add these, you will get 1. And if you just calculate these values are also less than 1 and greater than 0. We'll take one last example. Some 11 bags of wheat flour, each was marked 5 kg, but the actual weight was different. It was 4.97, 5.05, and stuff like that. So we have to find the probability that each of these bags chosen at random has more than 5 kg flour. So let's have 3 buckets, 5 kg plus, 5 and 5 kg minus bucket. So in 5 kg bucket plus, let's see how many are there. 1, 2, 3, 4, 5, 6, 7. There are 7 bags which weigh more than 5 kg. 5 kg is 1, 2. There are 2 bags which weigh 5 kg exactly. Less than 5 kg is 1. And 7 plus 4, 11. Total is 11 bags. Correct? So now we have to find the probability that each of these bags chosen at random has weigh more than 5 kg. So probability of 5 plus is nothing but number of bags of 5 plus kg weight divided by total number of bags. So number of bags with 5 plus kg weight is 7, by total is 11, that is 7 by 11. Please note here that when I am talking about the probability of more than 5 kg, I am not considering this bags which has weight 5 kg. And that's why it is always good to have 3 kind of buckets for these kind of questions, so that you can include or exclude based on the question requirement. So but there are some limitation of the experimental approach, and that's why I will go for the other approach in the higher classes, the one big limitation is the result is not consistent. So if I throw a die 100 times, you get different probability of head and tail. If I throw a die 10,000 times, I get different probability of head and tail. If I throw a die 10 times, I get different probability. Right? The result is not consistent. The bigger the sample space is, the better is the result, but the result is not consistent. And sometimes it is not possible to actually do the experiment. For example, if let's suppose a plane has crashed in a forest, and I want to find the probability of finding the plane crash in a particular area. So you can't do the experiment, right? You can crash the experiment to find the probability. Right? Or sometimes the experiment is that due to food poisoning, these many people died. You have to find some probability on that. So you can't actually poison the people with bad food to check. Right? So these kind of scenarios, it is not even possible to actually perform the experiment. So experimental approach has a lot of limitations. So that's why we'll go with the classical and the axiomatic approach in the higher classes. Quick summary of what we have seen, that event for an experiment is nothing but the collection of the outcomes of the experiment. The empirical or the experimental probability P is nothing but the number of trials in which the event E has happened by the total number of trials. Please note, P, very important formula, PE, the probability of an event E is nothing but the number of trials in which the E has happened by the total number of trials. Number of trials in which the E has happened by total number of trials, and the probability is typically between 0 and 1, 0 and 1 inclusive. 0 is a probability where the event is not likely to happen sure shot. 1 is the event probability where the event is likely to happen 100% sure shot. Probability is never negative and never more than 1. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot.